Yo, what's up? Hey, Jasmine.
Hey,
How are you?
I'm good. How are you?
I'm doing okay.
Nice, nice.
I'll think about the DP thing like later on. Like I have a
That's fine.
midterm next week, so yeah,
Oh yeah, yeah. Me too. Midterm season is starting.
yeah, I got so many things to do. Cool. Uh, uh, can you all hear my voice? Dope. Um, let's wait for 1 more minute. All right, never mind. All right, cool. So welcome back to Sys 187, and today we're going to talk about Next.js and Gatsby.js. Um, I guess like Cameron probably mentioned like get Next.js and Gatsby.js in the previous lecture, but I think he only like glanced through it and didn't really go deep into it. Probably on the side of Gatsby, but definitely not on Next.js. So today I'll like just go into pretty depth on what these two technologies are and why they're there. So before like going going into like these two things, I think it would be great to just look at like how content is rendered in a browser, because that really give us a notion of why we need Next.js and Gatsby.js. And next thing we'll talk about is client-side rendering and server-side rendering. That is, why do we need something more than just React? Because Next.js and Gatsby.js pretty much built upon React, but they, instead of doing client-side rendering, achieves like server-side rendering. So that is why they're kind of better than just simply vanilla React. And lastly, we'll like do some live coding on how you can use like Next.js and Gatsby.js. Um, and integrate it into your own projects. Very cool. So first of all, how is content rendered in the browser? Um, so when you're rendering content on a web page, the browser will use a thing called rendering engine. So for each browser, it will has its own rendering engine typically. So for Firefox, it uses something like GECKO. And then for Safari, it uses WebKit, and Google uses Blink. So the difference between all these like rendering engines are kind of like there are a lot difference between each of them, but I think they generally follow the same framework in how like they taking some input and show the content on the actual screen. So they do follow a common framework. So step one, what they typically do is that they build a document object model tree. And for those of you who didn't know the term, is basically the thing that consists of that makes up the web page. So for example, if I open up Chrome and then I go to inspect, then the thing here is called the DOM tree, document object model. So the reason why it's called document object model is because you can treat like this entire thing as a document, and in it has like all these objects of like head, body, and then div, and then anchor tag, h1 tag, like which stands for header one, etc., etc. So this is also organized as a tree structure. If you have taken like 160 or 121, then you can apparently see that under head there's like something else like meta tags, and then under body there's like div tags, and then under div tags there are like anchor tags, etc., etc. So it pretty much follows a tree structure, which is easier for traversal because let's say if you start at a div tag like this parent div tag, then you can go down one like depth deeper, and then you can see the other div tag, and then like even more content. Cool. So this is the DOM tree, and the first thing after you enter the URL, like say this one, and then you hit enter, what typically does is that the browser will send a request to the server hosting the website for this HTML. So we can try that out actually here. If we go to like network, and then we refresh the page, then cool. So like you can see like all these things are loaded. I think Cameron probably mentioned this last time as well, but I guess it's just a refresher for all of you guys. Like for example, this one and this one, those are requested to the exact same website URL as this one. And then it fetches the HTML back and then renders it. So that's pretty much the first thing each browser will, like, or each rendering engine will do. So it will take in the HTML files, and then for whichever CSS or JS link that is inside the HTML file, then it will send a request to fetch those data as well. So basically, after it sees that there's an HTML file coming in, what it does is that it will first convert the bytes in the HTML file to like characters. So here, basically, it is these that are converted. And then it will tokenize it and convert tokens to nodes. By converting tokens to nodes, it means, so for example, this div tag is a node. So when the browser engine first receives like this piece of HTML file, that is probably presented in bytecode. So, but bytecode is not like representable or can be directly used for user interface. So that's why the browser engine has to first convert that bytecode into like nodes that can be used in a DOM tree, and then it will put together all the nodes and then create the DOM tree, which is like this thing. And the second thing, so now we have all the like the actual like literal information, like for example, like um, let's see. So we have like the content, like for example, the 4, 16, etc. But then how do we actually display the information on the screen? We, as developers, we tend to do something that's called CSS. And I believe like all of you have touched on it before, like so far during the course. Um, so we as developer know how to write CSS, but how do like rendering engine actually process CSS? So pretty much this is the way they do it, which is kind of similar to how they process a DOM tree and with HTML files. So they just like taking the characters as well and then tokenize it and convert it to nodes and then create another thing that's also similar to the DOM tree as the CSS object model tree. Um, I think I don't have an example right now, but I guess you can just like treat it similar as something that's close to this DOM tree thing. So that's step 2. And after that, pretty much all information have been gathered into the rendering engine and the browser. So now the browser can actually, or the rendering engine can actually combine like the DOM tree and the CSS object model tree together and put them together as a finalized DOM tree, which is something you can see here. Because like when you look at this one, like for example, it has the style on it, like let's say style equal to outline none. But those shouldn't be there in the first place when only like at the step 1. Like at the step 1, you should not be able, like the rendering engine doesn't know that the style should be outline none. Like the style outline none only comes after step 3, where the rendering engine combines the DOM tree and the CSS tree. And then step 4, it will calculate the size and the position of like each element on the page. So what does that mean? It's basically like if you see here, like it has all the margin and border and paddings. So that is what the rendering engine will calculate and then it presents on the screen. And finally, the rendering engine, like having all the component that it needs, will just paint everything on the screen, and the user can finally see like the actual thing. Does that make sense? Like, do I have to repeat anything? Are we good? Okay. Yeah, so that's basically like how um, like the content is rendered in the browser. But so far, I think you can notice that we only have like HTML and CSS files, but something like JS files are missing. But JS like makes up a huge portion of how we interact with the browser or web pages. So where does like JS comes in? Um, so JS is kind of weird, or it actually lowers the efficiency of like the browser like building the pages, because whenever we like have to access a JS page or a JS file, like for example the one here, like the script source and then all these things, it will block the entire um, rendering process and then literally wait for all these like JS files to be downloaded before it can proceed to the CSS tree and the DOM tree and finally rendering the page. So the way you can prevent the blocking thing is either by assigning the JavaScript file to be like a sync, which is what is done here. When you say a sync, that basically means that you telling the rendering engine to, instead of waiting for the JS file to be like downloaded before you can like proceed, it will asynchronously download the thing and then do whatever it originally was doing. So one way is using a sync, and the other way is using the inline scripts above the CSS files. So another way you can do it is to include the link over here. So let's say, okay, this one. So if you do that, that will also prevent the JS file from blocking the entire like rendering process over here. Um, so that's why you often hear the suggestion that whenever you do JS files, you are recommended to use a sync rather than just like um, normal script tag, because that can increase the efficiency by a little. Um, yeah, but other than that, it works pretty similarly to the case without the JS file. The only thing that's additional is that after you have the CSS tree and the DOM tree, the initial DOM tree ready, you will run the JS file that gets downloaded previously. And then after that, you will build the DOM tree and then finally render the page. So this stage, while just being like one out of this entire whole flowchart, actually is pretty much takes a lot of time, because JS files is also has to be like converted from bytecodes to something like the rendering engine can understand, and then execute it. Like executing it also like takes a lot of time. So that is why like JavaScript files are tend to be we tend to like keep it as small as possible. And that kind of hints at why using React is not um, as efficient as possible when compared to like Next.js or Gatsby.js. But we'll cover that like later and explain that in more details. So this so different people have different approach into how like this rendering process is like carried out. Namely, there are like the thing called client-side rendering and server-side rendering. So client-side rendering is like CSR, and then server-side rendering is SSR. I guess this flowchart explains like pretty much all like we need to know for client-side rendering. So basically, the first step is like similar to what I have explained in the like previous slide. Like here, it will first get the HTML and then build a DOM tree, which is like the same over here. It will first like send a request to the server requesting the HTML files needed, and then the browser will start the parsing series. Will start the parsing like process, and then after that, it will download the JS files. But note that the thing with React is that everything is bundled within the JavaScript files. To see that, we can actually like see a code of a standard like React file. So for example, like this is how a standard React app is written. So you have a like index.html and then auto head and a link thing. And then, so here you will have a div of ID equals to root. Probably, wait a sec. Okay, I think this is better. Yeah. So normally we will have like this div ID equals to div ID equals to root, like this div tag, and then like after this, we would in this component in the source file, we will also have something that looks like this. So React DOM.render this app component and then document.get element by ID root. So this document.get element by ID root is referring to this div over here. And then after it sees like, so like basically this is instructing the rendering engine to look up in the DOM tree, and then whenever it sees a div with ID equals to root or an element with ID equals to root, then it inserts everything that's inside this app component into the React DOM tree. So that is why, but then remember that everything is like within this app component. So in this like index.html, basically nothing was there initially. Only after only after the rendering engine inserts like everything in the app component into the DOM tree will things be actually seen. So that is why after the initial request of the server sending the HTML files back to the rendering engine, like nothing can be seen until the browser downloads the JS and then waits for that and then executes React, can like everything be viewable and interactable. Does that make sense? Yeah, just stop me if you have any question. Okay, cool. So that is like client-side rendering, and that is how like React normally works. But as you can see, like during the first 3 stages, I can't really see anything. Um, so that is actually pretty bad in terms of both user experience and also in terms of search engine optimization, which we'll also talk about later. So that is why we kind of need a new thing called SSR, which stands for server-side rendering. So when you first request the server, the same HTML files get sent back. But remember that when that gets sent back, instead of like this, where nothing is in here, the server-side rendering, like HTML files, like do contain the elements that are needed to at least like show something on the web page. So that's why like after you first load the HTML files into your like browser, it will become like viewable, but not interactable. The interactable part is added by the JS file or the React component. So later on, like when we download the JS files and the browser executing the React, um, the web page can now be interactable. So like compare and contrast, you can easily see that SSR is like way better because you're able to at least see something before you interact with it, which is like the way like a lot of people or a lot of websites are doing like right now. Because like interactability can always like come a little bit later, but audience like often prefer they can like directly see the content after they load the web page instead of like waiting everything to be like compiled before they can see anything. Cool. So that is like server rendering, and like this basically explains like why we want server side rendering instead of client side rendering. So I guess one short example would be trying out like this example. Like if we do like site and then sys160.com, which I can do here. Site. Okay, so this is pretty bad. All right, before that, let me explain like what does this site do. So the site colon thing is like a Google or like Chrome like command line thing, like a little bit. Basically, what it does is that it um, shows all the pages that is crawled by the Google search engine. So when we go to like Sys160 website, there are like way more than just the homepage. Like when I click on homework, it has the homework.html. When I click on lectures, it has the lecture.html. And then there are even like lectures dot like whatever. like G/GT3 like PDF. So there's like definitely more than just the homepage. But what's like showing up here, or at least what Google is able, like Google search engine is able to crawl, is only the homepage. So that suggests like something is kind of wrong with this kind of approach. And if we do something else, like probably let's say, probably Cameron has shown this example. Like when we look at penlabs.org, we see that there are like way more than um, way more pages being shown compared to 160, compared to like this 160. Okay, cool. So in fact, I believe like every page on penlabs.org is actually shown on this like site :penlabs.org like page. If we go to about, yeah, like and then team, like it's even detailed to like every person. It's like every person's name is also like included in this result list, which is like compared to like this is way better, because when the user actually like search on penlabs.org, they can now be able to like see a lot more thing, and the ranking will also be higher in terms of the search result. So this like actually hints at a little bit of like thing comparing like client side rendering and server side rendering. Server side rendering brings a better SEO, like which stands for search engine optimization. So basically that means when you go visit a site, because the way like the content is rendered on the browser, it takes a shorter time for the browser to be able to at least like show some information compared to client-side rendering. So what that achieves is when Google's like search engine crawler tries to like fetch all these like web pages, they can go there and then see at least like, for example, if they set a timeout for each crawler to stay on each page to be like 5 minutes, or like shorter, like say 1 minute, then they're probably able to see like everything. If it's like server side rendering, then the crawler is probably able to see like everything up to the left um, of this line, like the first few stages. So now the crawler is able to see like the content here, and they're able to like um, show all these like pages, um, on the search result, since like the crawler is able to like fetch all those like information. But when you're using like client side rendering, then if this process of like showing like anything is like more than 1 minute, then the crawler will literally just like leave the web page and treats as if nothing is shown on the website. And so it cannot like report anything to the database, and the website like just doesn't looks good. So that is probably like why, like for sys 160's website, they can only show the web homepage instead of like anything that's like other than the homepage. Like for example, the homework page cannot be shown, the lectures cannot be shown, because the crawler is simply not being able to like seeing all those like information on the sites. So other than like better search engine optimization, there are also like some other advantages of like SSR, which including like shorter loading time and better performance. Um, I guess like it's kind of arguable that whether it brings shorter loading time, but from my perspective, if you're using like this approach, then at least you're able to, like comparing the time you're able to like see something between SSR and CSR. Then it takes like 3 stages before you can actually see something. But then for SSR, you only take like 1 stage, so or 2 stages, which is like kind of faster and then better performance, because um, you can see like something at least. Um, so I think that's like better performance and shorter loading time. So generally, that is why we prefer using like SSR compared to like CSR, if that makes sense. What the hell? Cool. So next, okay, so we're now clear that React, um, like a vanilla React app, um, can only achieve like client-side rendering. So how do we like move React to a server-side rendering thing? So this can be achieved by either Next.js or Gatsby.js. So we'll look into it. So for Gatsby.js, like their solution is to compile every React like JSX files into like static files, including HTML, CSS, and JS. So what that effectively does is whenever you hit the URL, um, instead of like having, oops, okay, okay, dope, cool. Yeah. So basically what Gatsby.js does is that it compiles like everything down to static files. And then when the the browser, like when you load this like um, URL, only the HTML elements will be returned during the first stage, and then after that it will be the JS, and then all the CSS and JS like assets like later on. So that will make us going from here, from like this rendering path to this rendering path, because now not everything is like bundled within this JS files. There are also like the content can also be seen with this within this index.html files. Um, so that effectively means that after the first stage, we're able to like have some viewable content compared to CSR. Um, yeah, so that is the benefit of like using Gatsby, and that's how like Gatsby achieves this SSR effect. So for example, we can have a look at this person's website, which is built using Gatsby. Um, so I think this is his personal website, but if we do the same like site trick, then we can actually see that the results is actually pretty good. We're able to see all the sub pages within his website, like not only the homepage, but also the cloud about portfolio design and etc. We're kind of not able to see like the a page that's like below that. Like for example, well, all right, like probably portfolio. Okay, yeah, cool. I don't think he has any like any more sub pages. But yeah, basically like this, like compared to what happens with like site160.com, is like way better. Yeah. So that is basically what I want to show. Like with using Gatsby, you can actually achieve like server-side rendering and let search engine better crawl your website and show like and put your website at a higher organic search ranking compared to like those that didn't use like all these things. Cool. So with Next.js, the solution is a little bit more complicated because Next.js like basically is more powerful than React, and so they use a similar approach that you guys did during the Campus Wire Light homework. So if you recall, whenever you're um, all right, actually let me pull up the code real quick. Um, yeah, like here, um, server. If we go to like server.js, then whatever that like how do like the server render something? Like it doesn't have like something that's similar to React where it says document.get element by ID root, and then React like DOM. Like we don't have this kind of thing. So how the hell in like Campus Wire Lite homework you can like actually able to see something? It's all achieved through this rest.render statement. So with that rest.render, it's kind of like you're rendering something from the server machine instead of like the client machine. So that is how um, in this homework you're able to like see, and then in the actual code of next.js, it's actually the same. So for example, this is my project on something else that's called Pen Basics, um, which is a project under Pen Labs. So here, if you read carefully, I also use like something as rest.status.json. This is not quite right, but like here, also use something like next app.render, and then with all these like things like wrapped inside. So that effectively does the same thing as rest.render the web page. Um, and that is like how Next.js achieves server-side rendering. So probably like during the like later on we'll look at how we actually implement next.js, and the way that is shown on the official website doesn't really show like next app or render. Like this is a more advanced usage of like next.js, but then under the hood next.js also like creates a custom, I guess, like creates their own server file, and then basically does exactly the same as rest of render. Um, so they also like doesn't um, like render the React app just from the client side. Cool. So with Next.js, you can use like you have like even more things that come along, except for just like server-side rendering, such as minimal configuration and then code splitting. Like with code splitting, um, I also kind of want to talk about it because it's pretty cool. Basically, this is the official website of Next.js, and then if we look at automatic code splitting, so what it's talking about is that whenever you import something, so for example, under pages, under this page, if you import like Calsay from Calsay browser, then this package is only included within the code for this page, but not this page. Because for index.js, it doesn't use Calsay. So ideally, the package that gets imported within page A should be only included in the code for page A instead of like page B. So yeah, as it says, every import you declare gets bundled and served within each page. So the page never loads unnecessary code, which is like also better than just normal React, because normal React, I don't think they handles this. And this is like better. Um, like this makes your browser works faster, loads faster. Cool. Um, I guess that's it for the theory part. Are there any questions that like you guys have? If not, we can move to the live coding part. Okay. Um, I think we can just talk about, like, do you guys want to know more about Next.js or Gatsby.js? Because I'm preparing to like do some Next.js thing. Because Cameron, I think he talked about Gatsby.js like in the previous lecture, and um, I don't want to do some repetitive work. Like I'm open to both because I don't really care. Like, I mean, I care because like I know both, so it doesn't matter which one I do. Okay. 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 Then I'll do Next.js. Um, and also like this are the articles I referenced during like preparing this lecture, and also learn a lot from all these lectures. So if you guys just want to read it after the class, then it would be dope. Like those are really short, but I think makes a lot of sense. Cool. So for Next.js, so if we go to like docs, and then we go to the old docs, and then scroll down a little bit. Cool. So this is the first line. We need to set up the project, which I'll do right now. Says so yeah, so like to the end, I'll also like compare Next.js and Gatsby.js a little bit because these two actually are kind of similar to each other, like in terms of how the code are structured. All right. And then I'll open up the code editor. Yeah. So remember, if you didn't do the npm init, just like do it afterwards, after you install the packages. And then after that, just like open up package.json and then do whatever is instructed here. Just like copy the scripts. Cool. Cool. I assume everyone is up to this point. And then as it says, like the file system is the main API, and then every .js file becomes a route that gets automatically processed and rendered. So we can just try like populate here, like the pages slash index.js. So to do that, I think first of all, we have to create a folder called pages. And then in there, we create a file called index.js. And then copy this code. And then, okay, cool. This is some like standard React code, so that should make sense to you. And then now, according to it, we just have to run npm run dev. Cool. So after you see the compile successfully, the green light, you should able to like go to localhost 3000 and then see the actual site. Cool. So now you see that it shows welcome to Next.js. So this is quite straightforward in terms of how you set up the entire like Next.js project. And then you notice here that there's a lightning logo here. So that is like what Next.js does to like make it fancier. Yeah, so notice that the entire setup is like no more than like 2 to 3 minutes. So that's why I said this entire thing that's like minimal configuration. Like it is pretty fast. Basically anyone can do it, I think. Okay. Uh, that's a good question. No, I don't think you have to do import React at the top of like that page because Next.js like automatically assumes that that's the case, if that makes sense. Like I would say like unless like Next.js complains about not having import React from React in some like specific files, you tend not to, you don't have to do that unless it complains. Yeah, cool. So now we have like this localhost file, like localhost page for us. Like instead of just doing like some React code, I think more I want to do is like glancing through this entire like Next.js like infrastructure, because I think that's like something that's unique to Next.js that a vanilla React app doesn't have. So one thing we can try is this hot reloading feature. So for example, if I change this next.js to like Peter, then it should like, you shouldn't have to like refresh the page to see the update. So that's pretty cool. And then as it says here, like everything under the /pages gets mapped to its to a route. So here you can see that it's like the slash, like the index.js gets mapped to the like slash route, because index like is by default the slash route. And then if we create like another page called page one.js, and then we like do a component to here, and then call it page one. So this is some ES6 syntax, and this is called functional component. And to even simplify this, we can do h1 this is page one. So, and then we should be able to see page one. Cool. Yeah, so this is also pretty cool about Next.js in that you don't have to like specify like at some point that you want the page one route. Like for example, in React, you would do something like import React router from like router from React router, and then do something like router and then path equals to slash, then you go to this component, and then path equals to slash like something else, you go to that component. So in Next.js, it's all like automatic builds. So you don't have to worry about like routing things. So, and then I guess automatic close billing, we've already talked about that. It basically like, I don't think we as developer are able to like visualize the effect of code splitting unless we like literally go to like the generated code over here and see like what's the code specifically for each page. But we can just trust Next.js that they do the good work. Cool. And then this is just like inline CSS that we can do like exactly the same with React. So specifically this one. So I can just like do the same thing. So for example, I feel like this is kind of plain. I want to change the color of it. Let's change to a cool color. Color picker. Let's say this one. Cool. Cool. There we go. So basically, it's just saying that we can do inline CSS as well. Yeah, and also like this is probably something that's kind of interesting. So what it's saying that you can create a public folder and then just include every image that's in that folder without having to specify the actual path. So we can also try that out. Basically, what that means is if you create a public folder in the root directory, and then you include, let's see, a picture. So I open public, and then I want to include my handsome face on it. Dope. So now I have my headshot, and I want to include it in the index.js. Then what I can do is import it. Let's see. So slash peter.jpg. Cool. Oh wow. Okay. Anyway, let's change the size a little bit. Wait, height 60 pixels. Okay. Cool. You see the meaning. Okay. So that basically is talking about like you can just refer an image under the public folder without having to do something like dot dot and then slash to go from pages folder to like go from inside the pages folder to to its parent level, which is here, and then like go to public and then slash peer.jpg. You don't have to do that. You can literally just say slash anything that's within the public folder. And then if you have like some folders within the public folder, let's say like images, then you can, if I put it inside, then you can say images slash peer.jpg, and that should work. Cool. Yeah, like the public directory, like the name public should be only reserved for this purpose. And okay, so this is also kind of cool that we can talk about. Okay. Okay, I guess this is the last thing I'll talk about like for today's lecture. Yeah, it's called dynamic routing. So basically what that means is like, let's say, if I hit this guy, then like this particular ID is kind of dynamic because it can also be like Armand, let's say. It can also be like Peter, let's say. So that doesn't necessarily have to be, oh wow, what the hell? Oh, it can also be Cameron. So it doesn't necessarily has to be like, it's not fixed. So how do we like cope with that kind of situation? So the thing that we can do is use this dynamic routing feature provided by Next.js. Yeah, so I can play around with that, or like we can play around with that. And then, so for example, like this page is under page 1, and then let's say we want to make a blog post, and then we have like multiple pages like under page 1. We also have like page 2, page 3, etc. Then yeah, let's just use this example. Then what we can do is instead of like creating, let me see, a okay, yeah, let's do this. So what I can do is instead of naming this to be page like 1, I want it to be like something like localhost and then 3000 slash page slash 1, like something like that. Right now it's like 404, but ideally it should not be 404. And how do we do that? So instead of naming it to be page 1, I call it a generic page.js. So this will no longer be page 1. And I import use router from next router. Cool. And then, so I do this thing. Dope. I want to return this. Okay. So here's just some like syntax thing. So after you import use router from next router, you have to like create an object from this called router, and then you're able to like get the page ID from this query object. So this query object, you can treat it as anything that's going behind the slash, like the slash. You can treat like the query as anything that goes behind this slash, because this page is going under, like if I literally just present this page to Next.js, then it will create a page at, it will create a thing at page. Oh, what the hell? Okay. Probably not, let's not call it page. I probably blog. Blog. Oh. Okay, anyway, okay, cool. So if we call it block, then we can see the thing. Probably page is a reserved word, so it doesn't want us to use that. Okay, but anyway. So after we have this, then everything that goes behind block is the query. Like this one would be the query object. So if we just like do this, then we should, like for example, I don't want it to be like a fixed like page one. I can say it's it's p id. Huh. Wait. Oh. All right. Wait a second. Wait a second. I think you have to create a new folder called blog, and then under blog you create a, like you drag it in, and then rename it as index.js. Oh fuck. Oh. Okay. I think I kind of fucked up. Let's look at the example we have. Router.query. All right, yeah, but I guess like that's the general idea. I don't want to waste your time because all right, but like essentially this like is what they're trying to achieve. So whenever you make a rel like post/1, you're able to like visit that file and then see the like getting this PID equal to 1. Or if you go to like /post/abc, you're able to like see PID equals to abc. And then you can like do a link from like other page. Like let's say you can do a link from like this index page um, using this syntax. And then once you click on this like first post, you're able to like getting routed to like this post page with the PID equal to like ABC. Like this href dot like equals to like this /post/PID thing is like referring to which path it has to like, gets routed to. And then this as is the actual detailed information that's should be like getting processed by this file or like that route. Um, cool. I think everything else is kind of advanced, so I will not dig like that deep into that. If you are interested, you can like read that by yourself. And I guess um, one more place you can read like really good um, Next.js code is the project I'm working on. So this is like fully built using Next.js, and then you can see like similar things under like pages. We have like all these like files. Let's say like food trucks. Then so use router actually works. Um, I didn't manage to like get it work this time, but yeah, it's the same thing where if you declare a use router object and then you can get the ID of that thing. Cool. So you can also like contact me if you have any question with like Next.js or Gatsby.js or anything with JavaScript in general. Um, so the thing I want to mention about so it'll be really quick, like 1 to 2 minutes. Like the thing that's similar between Next.js and Gatsby.js is that they all like have a common folder called pages. So with Next.js, with Gatsby.js, everything is under the source pages, and then like let's just go to my website. So I built my website using like Gatsby.js, and then this is like how Gatsby.js like general code structure looks like. And then once you go to like source, you also have like similar thing called like pages, and then that serves the exact same um, like purpose as Next.js, where if you go to like slash blocks, you are able to like see like all these like things, which is exactly the same as Next.js. So I guess that's the thing that's similar between Gatsby and Next. But other than that, they also have a public, like the same public folder that you can like put all your images or assets in there, and then like the static. And then route from that folder directly instead of like doing all the um, parent layer like dot dot slash thing. Um, yeah, but in the essence, like these two things are the state-to-art technologies that a lot of people are using. Like for Gatsby, like a lot of people are using Gatsby to like build personal websites and like small websites. And for Next.js, a lot of like enterprises or companies are using it to like build pretty good server-side rendering React apps. And it is also like extremely easy to migrate to like either one of these. So I guess if you guys want to try out um, like either Next.js or Gatsby.js in your final project, like if you want to do it, um, you're also like welcome to do that. That's like pretty cool. Yeah. Um, I think that's it for today. So does that make sense? Like any question? Um, if not, I guess that's the end. Yep, no problem.